She's like, hey guys, welcome back to my YouTube channel.
You need to get Alex to make you.
Hey guys, welcome back to the YouTube channel. J-Dog Does Math.
Yeah.
We are beginning integration by substitution. Now, I call this blobbage. Because, or blobbage. Yeah, this blobbage is related to the derivatives with blobs, right? How do I take the derivative of some blob to a power?
Bring down the power and multiply it by the derivative.
Bring down the power, leave the blob alone. That's what I always say, right? Lower the power by 1, multiply by the derivative of the blob. This right here, if we are taking antiderivatives or integrals, right? What happens is this right here has to be there. Any x term has to be there. We can fiddle or manufacture things with just plain numbers because we can always multiply by 1, right? But so if I am taking the integral of just an indefinite 3x squared plus 4, I'll keep it to the 4th, then I actually have to have the x. Now, a lot of teachers teach a thing called U substitution, and they show all these extra steps, okay? My thought is the same thing as we did when we simply tacked on the derivative of the blob, correct? What we have to say is, oh, the derivative of the blob has to be here and has to be complete. So what is, first of all, everybody recognizes the blob. Usually it's in parentheses, right? What is the derivative of that blob?
6x.
Well, we already had it up here. Yeah, it's 6x. As long as the x is there, you're good. We cannot manufacture x's. Put that on here. You cannot manufacture x's. You can only numbers, only constants, right? And so, all right, what some teachers will make you write out, well, the u is this blob, right? What is du? Or 6x dx, right? Or du dx is 6x, right? So then du is 6x dx. Well, how close are we to 6x dx? 6 away. Multiply by 6, and therefore 1/6, and we are multiplying by a fancy form of 1. And that makes it legal. Now, I don't usually go through all these steps. And in fact, other teachers will go, okay, let's change this to a u to the 4th. We did some manufacturing, so now my du is complete. And then we keep the 1/6. So then what do we do to integrate? Add 1 to the power, divide by the new power, and we would be done. Although, then we'd have to go back to x's. I skipped this trading or changing into a u by saying, oh, it's a blob to a power. My derivative of the blob is complete. I check it off. After I check it off, I ignore it. And then I take the blob, what do? Add 1 to the power. I leave the blob alone, right? Add 1 to the power, divide by the new power, keep the 1/6, and we'd have 1 over 30. Does that make sense? So, any questions here? So the real issue is finding the blob. Because if I had sine cubed x times cosine of x dx, how would I find that integral? What does sine cubed x actually mean?
Sine x all over cube.
The sine of x quantity cubed, exactly. If I write it like this, then I go, that's my blob, or that's my u, right? What is the derivative of that? Well, looky there. Guess what? It's there. I check it off, and then what do I do with this part?
Divide by 1 over cosine.
You ignore it.
Take it, and then you take it.
Once the derivative of the blob is there, I check it off, because when we applied the chain rule, we had to manufacture or multiply by the derivative of the blob, right? But if I take the antiderivative, do you see a 6x anywhere in there?
No.
No. So I literally have to have it there, and then I ignore it. So what do I do to a blob, for a blob to a power? Add 1 to the power, divide by the new power, power up. Divide by the new power.
So is the reason you don't divide by 1 over cosine in this, or multiply by 1 over cosine in this case, is because cosine x, the x is already there? Well, in the last example, you had to add the 6 to this there?
Yes,
Okay.
the cosine, but again, there is an x involved here. The only thing I could manufacture with a cosine or a trig function would be like the cosine of 1 or something, you know. I could not manufacture this. Like, if I had plain sine cubed x, I would have an issue. I actually would not have a terrible issue with this one. And I will probably never ask you one that's difficult. But
Could you make it like, could you make it sine x times cosine?
I can make it sine squared x times sine of x. And then I could go, wait, now sine of x is not the derivative of sine of x, but negative sine of x is the derivative of what? Cosine. So I could go back to my handy dandy trig identities, right?
Yeah, equals 1.
So the sine squared of x actually equals 1 minus cosine squared x, right?
Yes.
Now, I'm actually really close to a workable form. I would probably take the time and distribute, and I would probably, at least in my mind's eye, I would distribute that and then split it up. Minus integral cosine squared x times sine of x. Now, I know the integral of regular sine of x, right? Do y'all? What is it?
Negative cosine.
Negative cosine of x. Good. Now, this I could have just said it's cosine quantity squared, right?
Yeah.
That's clearly my blob because it's in parentheses now. What is the derivative of that blob, though?
Sine.
Negative sine of x, right? I have a minus out here. I mean, I could multiply by -1 times -1, but either way, it's going to end up being a positive right there and a negative there. And my derivative of the blob is complete. Check it off and ignore it, right? What do I do to this blob?
Power up.
Add 1 to the power, divide by the new power.
I have a power up in that room, so how do you?
Yeah, there-
They sound like a power out here in like Dragon Ball Z or something. They're nothing much like Captain America. They're a saint. I think that's very modern game.
let's do one more. Up until this point, you have been able to do this problem. But what did I make you actually do? Because I told you there was no product rule.
Oh, you made us
I made you FOIL that out and distribute the X, you know, and then have to do it separately. I have even, I'm not lying, I had a BC student, I mean like probably 5 years ago. Even if this was the fourth power, he would multiply it out. He would never use substitution or the chain, you know, reverse chain rule. I was like, because then I had to check his answer. It was terrible.
Maybe he did it.
Let's make that to the fifth power.
Why would you do that? I'm gonna do this just.
Let's make it to the
At
fifth
least we
power.
got the work.
Who wants to multiply that out 5 times,
Me.
right?
Josh, hey, why don't you do it?
But if we think of this as just a nice little blob to the fifth power, here's how I rewrite it every time. I leave a little space in case I need to manufacture something. And will I need to manufacture something, Aiden?
You can't.
That's you, right?
A
Yeah.
2.
Oh.
I can manufacture a constant, I just can't manufacture an X.
Oh, okay.
So the derivative of this blob is a nice easy 2x, right? So manufacture a 2 and a 1/2. 2 times 1/2 is 1. So it's a legal maneuver, right?
Yeah.
So what do? Power up. By the new power. I don't know how you write it. You could write it x squared plus 1 quantity to the 6 over 12 or just 1/12 times that. How do you feel about it?
Pretty good. Makes a lot of sense.
Mhm. Now I got a secant squared. What is the blob here? Is it the secant? Or is it something else?
It's before X. Isn't secant squared tangent?
The integral of secant squared x is just tangent of x. So I'm not thinking of this secant as my blob. I actually just have a pretty small blob, right? And the derivative of 4x is just what? 4 derivative. Hey, I understand jumping back and forth from derivatives to integrals is a difficult concept, right? So take the derivative of the 4x, we get a 4, and as long as it's a plain number, we can do 1/4 times 4. Check it off. The manufacturing process is complete. And the integral of secant squared blob is tangent of the same blob.
It's not as bad as the other stuff we were learning.
Now, there's some blobception that could be going on.
I just hate it backwards. I don't
So like,
trick hurts my little brain.
There goes the backpack.
Oh, this is the hardcore blob section.
Oh, lovely.
this would be blobs within blobs, correct?
Yes.
I don't know, maybe.
As I'm thinking about this problem, that sine cubed means we have a rather large blob to the third power, right?
Yes.
As I'm looking at that, what is the derivative? Ignoring the power, what is just the derivative of what's inside there?
Negative cosine.
Regular cosine.
Yeah.
Derivative sine is I know we've been going backwards, yes.
Yeah.
Derivative sine is regular cosine of the same blob times the derivative of the 6x.
Yes.
Well, looky there, we've got the x part.
Yes, sir.
So, and we have the cosine of the same blob. So let's group it all over. This is my thought process. I'm grouping it all with the dx because all of this is the derivative that has to be there, right? And we already said derivative of sine blob is cosine same blob times blob prime. So what are we missing for the inner blob? As As long as that's a number and no X, don't be tempted. There it is, derivative of the blob, check it off complete. What do we do to the power? Power up,
Power up.
divide by the new power.
Video game.
We get copyrighted for that.
Probably not
I
very
couldn't,
well.
I'm drunk.